So we've been studying trigonometric identities. We had to start on this yesterday, and today we'll finish it up. Yesterday we began by looking at the fundamental trigonometric identities with the reciprocal identities and the tangent and cotangent identities. These were reviewed from previous sections, but they needed to be recovered nonetheless, so that they're in the forefront of our minds. Then we began with the Pythagorean identities, thus coming from the Pythagorean theorem, dealing with a right triangle with side lengths of A, B, and a hypotenuse of 1. And we were able to derive each of these three Pythagorean identities and then create some common variations on the three. The next set we have here are the negative angle identities and the cofunction identities. To briefly review what those are about, we have the sine of negative theta being equal to the negative sine of theta. And the reason for that is this. If we take a jog back in our memories, the sine of an angle is related to the y value on the unit circle. So if I look at the unit circle, and I look at a negative angle, and some point that negative angle would take me to, the y value in this quadrant would have to be negative. For instance, -1. If I want that same angle value in the positive direction into the first quadrant, the y value would come out positive, like +1. So what we see is that the sine of the angle, a sine of a negative angle, is the opposite of the sine of the positive angle. For instance, -1 is the opposite of +1. Similarly, for cosine, being related to the x value of an angle, we have the negative angle taking us down into the fourth quadrant, for example, an x value of 2, the positive angle taking us to the first quadrant, giving me, again, a corresponding x value of, say, +2. So the cosine of a negative angle is equal to the cosine of the positive angle, just like 2 is equal to 2. No difference in sign there. The tangent, being the sine value divided by the cosine, gives us a negative divided by a positive. So for the tangent of negative theta, that would be like the sine of negative theta over the cosine of negative theta, which would be negative sine over positive cosine, thus giving me a negative divided by a positive, giving me a negative. The cofunction identities are then listed as follows. And I can get those by very cleanly looking at the graph of each of these. For instance, if I look at, let me turn off this second graph. If I look at the tangent, the graph of the tangent of pi over 2 minus theta, so that's my first one here, tangent of pi over 2 minus x, and I look at that graph, we get as follows. Now if I graph the cotangent function, so I'm going to go back here and I'm going to type in 1 over the tangent of x. Since I don't have a cotangent function on my calculator, I have to do 1 divided by the tangent of x. And I'm going to turn that graph on and graph it with a thicker line. We will see it overlay my original graph. There it goes. Thus demonstrating to me the equality of the tangent of pi over 2 minus theta being equal to the cotangent of theta. I can do the same thing for the sine of pi over 2 minus theta being equal to the cosine, and the cosine of pi over 2 minus theta being equal to the sine. So we get these cofunction identities. So that was the intent of yesterday's work, and today we're going to actually be putting these into use. For our first example, we will start that the cosine of theta is equal to -5/13, with theta being between pi and 3 pi over 2, thus putting me in the third quadrant, and me wanting to find the values of the other 5 trigonometric functions of theta. Okay. If you need to pause this to copy down the example, it might be a good time, but I'm going to keep on rolling since the pausing is up to you. I always like to start this type of problem with a picture. What does that angle look like? Well, I'm in the third quadrant from this part of the information. It says I'm in the third quadrant, so I'll draw a picture into the third quadrant. All right. I don't know what the exact angle is, but that's what it is. That's what I'm going to say it looks like. So that is theta. And down in this quadrant, in the third quadrant, I know the only thing that's positive is tangent. Okay, if we remember our old saying, all students take calculus, I can see that all things are positive here. Sine is positive here. Tangent is positive here. Cosine is positive here. We can also think that both in this quadrant, the x values are negative and the y values are negative, thus giving me cosine being negative, sine being negative, and tangent being the quotient of y divided by x, so negative divided by negative, it would come out positive. So tangent value is the only thing down here that's positive. So let's keep that in mind. Okay? So I start with cosine. That's a really good thing because almost everything we do rolls out very nicely if we can start with either the sine or cosine values and get the other one. So here I'm starting with cosine. I know the cosine of theta is equal to negative 5/13. And what that can lead me to is to find the sine of theta. And I do that, I look back at the identities that I have. And I'm going to look back through them until I find one that relates sine to cosine. And that is right here, actually. Sine squared theta plus cosine squared theta equals 1. I'm going to use that variation. All right. So sine squared theta plus cosine squared theta is equal to 1. I don't know what sine is, so this will stay sine squared theta. But the cosine, I do know what that is. That's negative 5/13. So negative 5/13 squared equals 1. So that gives me sine squared theta plus 25 over 169 equals 1. Take away 25 169ths from both sides. And that gives me sine squared theta equals 144 over 169. I got that just by subtracting these. If you're not comfortable with the fraction work, just use your calculator, okay? Now when I take the square root of both sides, I get the sine of theta equals positive or negative 12/13. Now, given that I am in the third quadrant, I'm down here, and I've already stated that the sine is negative, only tangent is positive down here, I'm going to state, okay, the sine of theta must be negative 12/13. And that's because I'm in quadrant 3. Okay? So the sine of theta is negative 12/13. I'm going to put that value aside now that I have it calculated. Okay? And I'll get rid of the rest of this and we'll move forward. Unless you need to take notes, then copy that down. Oh, sorry, that's not what I wanted. Let me try that again. A little technical glitch. This is the button I meant to push. Okay, I now have both cosine and sine. How can I find, let's say, the tangent? Well, going back through the notes until we find somewhere that relates sine, cosine, and tangent. Oh, yeah, right here. Sine, cosine, and tangent. So I'm going to say that the tangent's equal to the sine value over the cosine value. Okay. So tangent of theta is equal to the sine of theta over the cosine of theta. So the tangent of theta is equal to negative 12/13 over negative 5/13. Okay? If I put that in my calculator, or if you're comfortable with fractions, but if you do this in the calculator, make sure this is a set of parentheses and this is a set of parentheses. I get the tangent of theta is equal to 12/5. And I really like leaving it in fraction form. It makes other things simpler down the road. So please leave this as a fraction if we're already working in fractions. So there's the tangent value. And it came out positive, just as I said it was going to. Okay, no option for it to be negative, actually. And I will set that one aside. Okay, now I've got sine, cosine, and tangent. I love getting those first because now the cofunction identities give us all of our cofunctions. For instance, cosine. Well, cosine's related to secant. It's the reciprocal. So now I can write what the secant is. The secant of theta is the reciprocal of the cosine, 1 over the cosine of theta. So here's my cosine. The secant must be negative 13/5. Okay, cosecant. Well, that's the reciprocal of the sine of theta. So that gives me 1 over the sine of theta. So that's negative 13/12. And then finally, cotangent. That gives me 5/12 because it's the reciprocal of the tangent. 1 over the tangent of theta. So 5/12. I think I mistakenly called those the cofunction identities when they are actually the reciprocal identities. And we have that listed back here with the reciprocal identities, so I apologize for that. So I've got all of my values. I started with the cosine, drew a picture so that I knew what was positive, what was negative for the quadrant that I'm in, quadrant 3. And then first found the sine using the Pythagorean identity, then using the sine and cosine to get tangent, and then my reciprocal identities from those 3 to get the last 3. All right. Example 2, this is another thing that we can do with all these identities, is simplify expressions. So when I'm simplifying an expression, I want to get it down to the least number of terms and the least number of functions. This expression here has 2 terms. It has this term and this term, and it has 2 functions. It's got a cosine function and a sine function in it. I want to get it down to the least number of terms, least number of functions. So ideally, this would turn into 1 term and 1 function. I don't know if that's going to happen, but that would be the ideal. So let's see what we can do. As I'm looking at this, I don't see any of the identities we covered previously jumping out at me. However, one of the ones I encourage you to look for is whenever you see a sine, cosine, or tangent, or one of the other functions being squared, that I want to think Pythagorean identity. So if I stroll back to the Pythagorean identities, I can see these squaring items happening. And specifically, I'm dealing with sine squared. So I've got sine squared theta plus cosine squared theta equals 1. However, I have sine squared by itself. So I'm going to look at that variation that we wrote down on the Pythagorean identities, that the sine squared is equal to 1 minus the cosine squared. So this sine squared part, using a Pythagorean identity, will be changed a little bit. So this becomes cosine theta minus cosine theta times, now this is where I'm going to change this from sine squared to 1 minus the cosine squared of theta. There we go. All right, so with that in mind, let's see if we can simplify this a little bit further. What happens if I distribute this negative cosine theta to each of these terms? Let's see what happens. That gives me the cosine theta from the first one minus cosine theta times 1, so minus cosine theta. Now negative times a negative comes out positive, so I get plus cosine cubed theta. Oh, well this is nice. These two cancel each other out, leaving me with just cosine cubed theta. I am now down to one term with one function. That's as low as I'm going to go. I don't always get that far, but if I can, that's great. And here I got down to one term, one function. It is now simplified. Can't go any simpler than that. Let's get a little bit more involved with a larger expression. Don't let all of the terms and everything here freak you out, because there's some familiarity we're going to see in this problem. Looking at it, I look for anything that might resemble one of our identities that we have. And I vaguely remember something having to do with this, the pi over 2 minus theta. Sine of pi over 2 minus theta. So strolling back through, I find this co-function identity. So the sine of pi over 2 minus theta is equal to cosine theta. So I'm going to replace this with the cosine of theta. So 1 plus cosine theta over secant of negative theta. Now, I don't have anything that deals with the secant of negative theta. However, I do have some things that deal with other negative angles. I've got sine of negative theta, tangent of negative theta, cosine negative theta. Nothing with secant. That if we remember that secant is equal to 1 over the cosine, I can kind of take a multi-step process here. Bear with me. This is going to turn into 1 plus cosine of theta, nothing changed there, over 1 over the cosine of negative theta. So I've replaced this with this. Now, the cosine of negative theta was just equal to, if I stroll back here, cosine of negative theta is equal to cosine of theta. So I'm going to change this to being 1 plus cosine of theta over 1 over cosine theta. Now remembering back to an algebraic principle, instead of dividing by a fraction, I multiply by its reciprocal. So my 1 plus cosine of theta is now multiplied by cosine of theta over 1, or just cosine theta. Cosine times cosine, that's cosine squared, so 1 plus cosine squared. And as I mentioned a moment ago, whenever I see something squared, I'm thinking Pythagorean identity. So I'm going to scroll back to my Pythagorean identities, and I see on here, let's see, sine squared plus cosine squared equals 1. I also see cosine squared equals 1 minus sine squared. Sine squared equals 1 minus cosine squared, but this is minus, and if my memory serves right, this is plus 1 plus cosine squared. So I can't make that relationship. If this was 1 minus cosine squared, I could rewrite this whole thing as sine squared. but this addition doesn't match up with the subtraction that I need here. So I'm not going to use it. Thus, this is as far as I can go right here. I got down to two terms and one function, so that's pretty good. Not quite as good as one term and one function, but it is still pretty good. So those are the problem types that we're going to see with this work. By no means is this meant to exhaust all the examples that you're going to see. These really, the door is wide open on these. There are so many different things we can do and encounter with them. You just need to sit down and practice them. Use a positive attitude, it will really help. It's easy to feel defeated with this. I do want to mention that there's no one way to solve these. And that's kind of the beauty of it, is you really get to use creativity when solving these problems. So please try and feel creative, try and have an open and positive approach to this, and have some fun. Okay? Play around with this stuff. Here's the homework set. Good luck, have fun. I will see you tomorrow.